Maintaining aging civic monuments costs municipal governments millions in overhead for space that public agencies no longer fill. Even without staff inside, these structures drain city balance sheets. The baseline upkeep, utility bills, and massive debt service payments continue to compound month after month. Meanwhile, venture-backed biotechnology firms are aggressively hunting for space. The life sciences sector currently faces a critical shortage of specialized research real estate. Building a purpose-built laboratory from the ground up routinely takes 3 to 5 years. Complex supply chains, fluctuating material costs, and lengthy site approvals create a severe bottleneck for companies that need to start testing immediately. Those vacant municipal liabilities offer a highly practical alternative. Their structurally robust shells stand ready in urban cores, providing an immediate footprint that lets life science companies skip years of construction delays. Curious, mid-century administrative halls and judicial chambers were heavily engineered to handle large volumes of paper files and public traffic. They are physical fortresses. That robust engineering perfectly matches the extreme demands of modern bioscience. Operating heavy research equipment safely requires reinforced floors that can withstand massive concentrated loads without bending or vibrating. Reinforced concrete floor slabs in these civic structures were poured to bear 125 to 150 pounds per square foot. This easily accommodates heavy machinery, supporting centrifuges and mass spectrometers. The buildings also feature high clearances and wide vertical utility shafts. Because those architectural bones are already in place, retrofit teams can skip primary construction and focus strictly on specialized interior work. They install modular cleanrooms, acid-resistant drainage runs, and high-volume air systems. By utilizing these pre-existing structures, developers eliminate the need to install costly primary duct chases or poor subfloor reinforcements. Adaptive reuse turns a space designed for local bureaucracy into an advanced research environment for a fraction of the structural cost. Physical engineering isn't the only barrier to getting a lab operational. Time and municipal policy are equally restrictive. Building a new suburban business park forces developers into a maze of multi-stage civil grading reviews and environmental impact assessments. Reusing certified urban foundations bypasses those entitlement processes entirely. A comparative bar chart illustrates the environmental advantage. The tall bar shows the massive carbon footprint of a new build. Preserving an existing structural core drops upfront embodied carbon by 40 to 60%, actively shielding projects from strict municipal emissions penalties. There is also a significant geographical advantage for recruiting. Centrally located civic plazas are already linked directly to major public transit hubs, making them highly desirable for specialized bioscience talent who prefer walkable downtown neighborhoods. Combining pre-approved downtown zoning with immediate transit access allows biotech firms to skip years of red tape, embedding their teams right into the city center. For mid-sized cities, converting an underused administrative hall into an innovation hub turns a massive public expense into a reliable revenue source. When municipalities establish public-private partnerships on these sites or lease them out directly, they secure private infrastructure investment and gain stable commercial tax revenues. This vector map visualizes the economic ripple effect. As research hubs bring foot traffic to quiet corridors, expanding heat map waves show commercial activity returning. The influx of teams creates local demand, specifically reviving neighborhood retail, hospitality, and the technical suppliers supporting these labs. As modular lab components become common, developers deploy prefabricated biosafety pods and drop-in utility distribution frames to rapidly scale this urban renewal across diverse historic footprints. Rather than letting aging public buildings drain municipal funds, cities can preserve their architectural heritage and provide the exact structural foundations required for the next generation of scientific discovery.